Welcome back to the Python programming series. In the previous module, we wrote our very first Python program and learned how to display information using the print function. Well, today, we're tackling one of the absolute most foundational concepts for any beginner. Honestly, it's the backbone of almost every single script you're ever going to write: variables and data types. I mean, almost every program you create is going to use variables because they allow us to capture, store, and manipulate information efficiently. Let's get into it. Okay, let's kick things off by looking at a famous guiding philosophy in the Python community. You might have heard of it. It's from Tim Peters in The Zen of Python, which is basically a collection of principles for the language. He says, readability counts. This is so important. It reminds us that our code really needs to be clear and communicative for humans, not just computers. So as we learn about storing data today, we're going to prioritize making our code incredibly easy to read. Here's our roadmap for today's explainer. We'll start with welcome to variables, move on to naming your variables, break down the 4 data types, look at variables in the real world, and finally wrap up with your coding challenge.
All right, Section 1. Welcome to Python variables.
So what exactly is a variable? Technically, it's an identifier acting as a container. Under the hood, Python works by binding names to data objects. But for right now, just think of a variable as a labeled storage box. It's like a giant puzzle piece. The variable name is the label you scribble on the outside of the box, and the stored value is the actual information you tuck inside it. And this right here brilliantly illustrates how incredibly simple Python can be. Notice how we just write our label, name, followed by an equal sign, and then the value we want to store, which is Alex. That equal sign, that's our assignment operator. We're literally assigning the value of Alex to that variable container we called name. Simple, right? Once you do that, Python securely remembers this object in its memory. That means we can reuse the variable later without retyping the whole original thing. If we passed our variable into the print function, boom, the output is simply Alex. Instead of writing the actual word out over and over and over, we just reuse our handy label. But, variables are called variables for a reason. They can vary. They're dynamic containers. Say you assign a value of 10 to a variable called score, and then later in your code, you assign the value 20 to that exact same label. Well, the latest value automatically replaces the previous one. So when we print the score at the end, the output is 20. The old value is just gone. Moving on to Section 2, naming your variables. Let's see how we can adhere to that Zen we talked about. Now, good variable names make programs infinitely easier to understand. While the computer understands both of the examples on this slide perfectly fine, naming your variable student_name instead of just X totally embraces readability. It clearly communicates your intent to other developers, or let's be real, to yourself when you look at the code 6 months from now and have no idea what X was supposed to mean. There are some strict rules you absolutely must follow when naming your boxes, though. You cannot start a variable name with a number, so one name will throw an error right away, but name1 is perfectly fine. You also can't use spaces, which is why we usually use underscores to separate words. Also, Python is entirely case-sensitive. A variable named age with a lowercase a is a completely different container than age with a capital A. Oh, and surprisingly, thanks to an update in Python 3, it even allows non-ASCII characters. That means you could technically use a word like the Swedish smörgåsbord as a variable name. Crazy, right? So, the crucial takeaway here is you can use almost any custom label you want, except for these specific reserved keywords. Words like false, await, import, or yield. Python reserves these words for its own internal syntax and structure. If you try to name a variable import, Python is going to get very confused and throw a syntax error. Just steer clear of these. All right, Section 3, the 4 data types. Time to look at categorizing data. This matrix summarizes the 4 foundational pillars of data types that you're going to use constantly in your applications: integers, floats, strings, and booleans. Let's break down each one so we can understand exactly how Python categorizes the data we feed it. First up, the integer. An integer is simply a whole number. Think 30, 5, or -100. In Python, these can represent numerical values in a virtually unlimited range. Unlike some older programming languages, Python handles massive integers natively. You're really only restricted by the available memory on your machine. Contrast that with a float, which is a decimal number, so 1999 or 5.9. Actually, even if you write 5.0, Python treats that differently than the integer 5. Behind the scenes, Python allocates memory and processes whole numbers and decimal numbers using entirely different mathematical structures. It's kind of fascinating.
Now, if you're ever looking at some code and you're unsure what type of data you're working with, Python has a great built-in tool for that. You can quickly use the type function. Wrapping our age variable in the type function outputs int, confirming Python recognizes it as an integer. Super handy for debugging.
Next up, we have strings. Strings just represent text, and in Python, they're always enclosed in either single or double quotes. What's incredibly powerful is that you can manipulate strings algebraically. You can use the plus operator to combine or concatenate multiple strings together. So, hello plus the variable Sarah forms a complete readable message. It's like snapping Lego bricks together.
Finally, we have booleans. Booleans represent fundamental truth values, simply true or false. Under the hood, they actually behave exactly like the integers 1 and 0. While they seem incredibly simple, booleans act as the primary engine for making logical decisions in your scripts. Later on in the series, we'll use these with if statements to control the flow of our entire program. They're an absolute game changer.
Okay, moving to section 4, variables in the real world. Let's look at some practical applications. Imagine you're tasked with creating a student information system. You wouldn't just use one type of data, right? You'd store the name David as a string, an age of 21 as an integer, a grade of 88.5 as a float, and whether he passed as a Boolean set to true. By combining multiple data types simultaneously, you build a complete, readable profile. A real application just scales this up, using thousands or even millions of variables all working together. The real beauty of Python lies in how it handles all these variables. Compared to a high-performance language like C++, which requires complex syntax and manual memory management, where you literally have to explicitly declare what type of data a variable will hold before you use it, Python uses what we call dynamic typing. That means Python figures out the data type on the fly based on the value you assign to it. This is exactly what makes rapid development, code readability, and writing automation scripts so incredibly efficient in Python. Finally, Section 5, your coding challenge. Time to test your new skills. So, are you ready to build your own profile? Can you apply what we've just covered to accurately represent yourself in Python code? Think about the different facets of your identity and how they translate into strings, integers, floats, and booleans. Here's your mini challenge for today. Open your code editor and complete these 4 steps. Create a string for your name, an integer for your age, a float or integer for your favorite number, and a Boolean asking if you like programming. Try it out. Today you learned what variables are, strict naming rules, and the 4 essential data types. Next time, we'll leverage operators to make Python perform complex calculations. So as you look at the thousands of apps on your phone today, ask yourself, how many millions of precisely labeled variables are working together behind that screen right now? Keep coding, and I'll see you in the next explainer.